Hi guys, happy Thanksgiving. I thought I'd do a little video on a couple of things. I'm going to try to put this all in one video. Hopefully it will fit, which means I probably won't be doing justice to either one of the subjects, but it was something that I kind of wanted to do. The first thing, which actually goes in part of the other part of this, or the second half of this video, is talk about decibels and what they are, how they're figured, rough, basically. A little history. Decibels comes from bells, or bell is a measure of power. Although bell is a fairly large number, so we generally use deci, which is 1/10. It came from Bell Labs developed the bell for measuring line loss in telephone lines, and they basically, when they first did the workup, they found out that they needed to use more or less a decibel. And of course it's named Decibel, or bells, from Alexander Graham Bell. But just to give you a little bit here, now wait a minute. For when you're looking at bell, the bell, or just bells, it works out what it is log base 10 power out to power in. So relationship, ratio. The decibel is 10 log base 10 power out to power in. So this is the bell, this is decibel. Now, what is log? You may ask, some may ask. Well, log, basically, all log is, and I put a little 10 down here. You won't normally see it that way. Log can have any base number. You can have log base 2 or whatever, 2, 3, 4, whatever number you want. The standard log is base 10, and consequently we don't put the 10 there. I just put it in here to show it. But on your calculator, the log you see on there is base 10. And what log gives you is an exponent. So basically, if I take log, and I'll put the base 10, because that's what I do, of 100, that is 2. Because 10 from the base 10 here squared from the 2 equals 100. Log base 10 of 1000 is 3, because 10 cubed is 1000. Now again, you can have any base you want. If you have log, say base 2 of 16, that's 4, because 2 to the 4th power equals 16. So you can have any base, but generally you will deal with base 10, and generally you will get rid of, I have to show 10 there anymore. But all logs given you is the exponent. And it's the exponent of whatever base you're using, in this case, regular logarithms base 10. Why log? Because the human hearing and sound, well, more or less sound actually, moves through a medium and can be measured using the decibel, can be measured roughly with logarithms. It's very close to standard logarithm, base 10. It's actually accurately measured in natural logs, but natural logs, the numbers get really cumbersome, so we don't get nice round numbers as a general rule, so they're not generally used, but the decibel approximates it real close. So that's what you hear. And your audio taper potentiometers and your volume controls are called audio taper. The old days they used to call them logarithmic taper, and some places still do, because they are logarithmic tapered. Log, base 10, logarithmic taper to them. That's what audio taper is. Now, it turns out that if you'll see, you know, a decibel number, say 30 dBs, and what does that mean? Because remember that it's 10 log of P2 to P1. Input, output. And I could say that that's 30 dBs. You know, that works out to 30 dBs. But I still don't know anything. I need to know what the reference is. This bottom number. I need something. This is 30 dBs. Now, one other thing about decibels, they can be positive or they can be negative. Negative, they generally call them dB down, but negative means that P2 is smaller than P1. It's a smaller number. Positive, P2 is greater than P1. So if it's a negative decibel, that means the output power is less than the input power. If it's a positive decibel, the output power is greater than the input power. So I just wanted you to know that. But you still need to know what input, what references you're considering. Well, eventually they decided to develop some standards. And the most used standard, or pretty well set standard, is the dBm. And what does that equal? That is 10 log of P2, the output power, related to 1 milliwatt. So they decided to pick P1 as 1 milliwatt. So whatever wattage is here, whatever output, whether it's in milliwatts, watts, whatever, do the simple math of this ratio, this division here, and then take log of that times 10 and you get your dBm. So you'll see a lot of numbers wrote, you know, they'll tell you, you know, it's 30 dBms or 10 dBms or whatever, or minus 10 dBms or whatever. That's what they're talking about. The M stands for 1 milliwatt, and that gives you a standard on it. Now, decibels don't have to only measure power. They can measure voltage and amperage ratios, but we'll look at voltage mostly. In voltage gain, dB of voltage gain, and there is two ways of writing it. It can be dB large V, but the more common way is dB VG, voltage gain. So dB VG, small g, small v, small g, is 20 log of voltage out over voltage in. Now, all of a sudden I got a 2 here. I got 20 instead of 10. There's a reason for that, is because P, power, wattage, equals V squared over R. And that 2 comes from the squares right here. The neat thing about logs is this actually equals the same thing as this, 10 log of V squared 2 over V1 V squared 1. But I can take that 2 and move it to the front and times it times that 10. That's the nice thing about logs. I can just take this and move here, the squares. So that's where the 20 comes from. That's to measure voltage. Now there was a standard mainly used for microphones, a dB small v, which is 20 log of voltage out over 1 volt. The standard was 1 volt and is 1 volt. That's generally used only for voltage gain in microphone systems. But in amplifiers, whether RF amplifiers, audio amplifiers, radio receivers, things of this nature, figuring out the gain of each stage, generally you can just use the voltage gain and use this, because you already know or already setting a input, so you don't need a standard. You'll know what your input is, and you have your output measured with a certain input that you measured, and that gives you the dBVG, or the gain, voltage gain of the amplifier. That's all I'm going to say about decibels. It is a very quick little thing on it. It doesn't do it justice, so if anybody wants me to, we can go a little bit deeper into it. It really could use its own specialized video, but that covers the primary things you really need to know about it. But anyway, the other thing I want to talk about is where some of this is used, and that is the 2 S's, or to a certain extent you could say 3 S's, but the third one is used only for certain receivers and actually used for working out measurements of the first 2. But the 2 S's of radio specs or receiver specs. And what are they? We have sensitivity, and selectivity. And the other one is signal to noise that you might run into. Not so much in old tube radios and stuff, but you might run into newer equipment. What is sensitivity? And the only reason I want to do this is because sometimes these get confused. And what is sensitivity? Well, the actual definition basically is it's a measure of the input required to give a standard output. Now, what does all that mean? It's Well, what that means basically, in a nutshell, it's actually a measure of how weak of a signal a receiver can pick up legibly, audibly. Not the signal you might pick up out there that is, you have your ear right up against the darn speaker and you got it cranked right up and you're going, I think I know what they're saying. No, this has got to be just a normal radio signal or standard output, wherever you're comfortable sitting listening to that radio, the weakest signal that you can turn in and pick up and hear sitting at that spot with relatively normal volume level, not so high that it may be distorting or pushing the speaker to its ultimate end. So basically it's a measure of how sensitive the radio is a measure of how weak of a signal that it can pick up that you can understand without any problems. And that's all sensitivity is. So if you want to look at it another way, is look at it from a standpoint of a more sensitive radio will pick up more stations. A less sensitive radio won't pick up as many stations. So the more sensitive it is, the more stations it's going to pick up. Now, selectivity is well, basically it's a measure of the radio's ability to attenuate out unwanted signals. Basically what selectivity is looking at is adjacent channels, especially stronger ones. So let's just, to give an example, let's say that you got a radio station you like listening to, say around 1010. Say right on 1010, and it's a little bit weaker station than, say, a station at 1020. A good selective radio, a radio with good selectivity, will pick up 1010 without picking anything up on 1020. It won't have any unwanted modulation from 1020 interfering with it or ghosting in on it. And that's what selectivity is. It's how selective the dial is, the radio is, when you set that dial. And it's a measure of looking at the adjacent channels, especially when they're stronger. And in fact, that's how you measure it. You're looking at a stronger signal than the one that you want. And how well can that radio take and attenuate that weak station or completely not allow it through. So, give me a second. If you've been hearing the noise in the background, it's my scanner. I got to turn it down. Sorry about that. But anyway, that's what selectivity is. Both these are generally measured in dBms. But sometimes they may have some other measurements that they use. That depends on the manufacturer and their specs, what they want to use. But if they're whatever they're using, they will tell you. Generally, they'll have a note there telling you how they measured it, what the measure is. Now, signal to noise ratio is another one, and basically it's just what its name is basically a measure of how well a radio can pick out a signal in the background noise and amplify it and leave the noise alone. Not amplify it or attenuate it away. And generally signal noise is used in both of these when they're actually measured, and doing the measurements of both these when a radio is being tested and stuff at the factory, or a design's being tested. Of course, sensitivity is coming from how much amplification gain you have. So if you look at a radio, some radios have an tuned RF amplifier before the mixer tube, and that's going to actually make the radio more sensitive, because you're amplifying what the antenna is picking up before you even send it into the mixer converter tube to be mixed with the local oscillator. So now you've got a much stronger signal there that gets mixed and then goes into the IFs. Already it's going to be stronger than a radio that doesn't have that, so consequently that radio is going to be more sensitive than a radio that doesn't have that first amp in there. As far as selectivity, it will be looking at both the very front end, at the tuning circuitry, the RF tuning, the filtering in there, the tank circuit, how it's all designed, how selective it is, and then the IF and how narrow banded the IF is, to make it as selective as possible to only feed that one signal through. Both also will be working with, once the signal is detected, in the audio circuits. Consequently, a more powerful audio, in other words, if you got push-pull in a radio as opposed to single-ended, then you can actually say it's going to be a little more sensitive, because it will amplify even the audio of a very weak station that is able to get through and get detected and bring it out loud and clear. And selectivity, especially dealing with signal noise selectivity, will be done, a lot of filtering done right in the audio stages. So I think this video is long enough. Probably by the time this gets uploaded, and when I am uploading it, it'll be this evening. So guys, hopefully you'll had your stomachs filled and maybe want to take a little shot out looking on YouTube and watch the video. If you have any questions, leave them in the comments and I can go over the a little bit more on this. One last little bit piece of this that I want to do, just as an added note to this video, is I got a comment, and it was from somebody that I cannot reply to, and he watched the Craigslist, another Craig's thing video, that last video I did on that Philco 95 when I showed it, and his question was wondering why each RF stage in a TRF is tuned, and I want to answer that in a real nutshell quick way on this video. The reason that each RF stage is tuned is to keep, well, basically is to keep the selectivity. If you let an amplifier, basically what they call open-end run, what happens to it is it can introduce a lot of problems. It can actually itself pick up, or its circuitry pick up unwanted signals and then amplify those in with what you tuned in. Each section of any amplifier, each stage of a radio and everything, all that circuitry, it can act as an antenna, because tubes are high impedance, so it don't take much to get a signal into a tube. So in order to stop that, every stage is not only well shielded in a TRF, or at least attempt is made to make it as shielded as possible, but each amplifier, RF amplifier stage, is then also tuned, so that each time we amplify that signal, as we go from one stage to the next, we're only amplifying what we want to tune in. and nothing else is interfering in. Anything, whether it's in the amplifier stage itself due to capacitances and stuff in the circuit, or as well as anything external that might make it past the shielding, will not be able to move on to the next stage because of that tuning. So the whole reason for tuning each one is so that that's only frequency that we're amplifying through, no matter what number of stages it is, whether it's 3, 4, or 5 stages. So that's in a nutshell why each stage is tuned, and it's basically to make the radio more selective, cut down interference, distortions, and harmonics, and other problems from happening. So that made this video long enough. So I wish everybody who is in the States anyway, and around the world that might celebrate Thanksgiving. Anyway, I wish you all a happy Thanksgiving, and try not to eat too much, and just have a good day and enjoy yourselves. And to everybody else, you all have a good day, and thanks to all of you for watching and commenting, and I guess I'll see you guys on the next video. Have a good day.